Hello, my name is John Kelly and this is the Weber Auto YouTube channel. Today we are going to talk about the ZF or ZF 8 HP series automatic transmission. This is a 8-speed rear-wheel drive or all-wheel drive, four-wheel drive automatic transmission, and it is used by Chrysler in many of their vehicles, including the Dodge Charger, the Chrysler 300C, the pickup trucks, and so on. It's also used by other vehicle manufacturers. But this 8-speed rear-wheel drive transmission is one of just a few 8-speed rear-wheel drive transmissions in the world at the moment. There's a Ison 8-speed that Toyota, Lexus, Cadillac used. General Motors has their own version of an 8-speed, and then there's this ZF 8-speed that I'm aware of. There may be another one out there, but these are the only three that I'm aware of. And I've got my hands on a ZF 8HP70 today. Now the 8HP is the series of automatic transmission, and then the last two numbers after it indicates the relative amount of torque the transmission can handle. So a vehicle like the Dodge Hellcat with the 707 horsepower, it's going to use the 8HP90, where the regular pickup trucks use the 8HP70, and there's a 8HP, it's either 35 or 45, I forget, that's used with the V6 behind a V6 in vehicles like the Chrysler 300C. And so I wanted to show you the parts and attempt to show you the power flow through this transmission. But as I've found out, showing you the parts is going to be easy. Showing you the power flow is not going to happen on this transmission. You're just going to have to read about it. I will show you the components and how they all fit together, but this is an incredibly complex mechanical transmission. Now, as far as a service standpoint, it's not very difficult to disassemble and inspect and reassemble, much like any other automatic transmission. But this transmission has 4 planetary gear sets, and the way that they are arranged makes it to where I cannot show you what I'd normally like to show in all my videos is the power flow through the entire transmission. So here's our input shaft for this transmission. We've got the splines right here that hook to the turbine and the torque converter. So if this input shaft spins, we have an input to the automatic transmission. Well, right here in the middle of this input shaft, we have the second. Remember, there's 4 planetary gear sets in this transmission. They're numbered or identified as P1, P2, P3, P4 from the front of the transmission to the back of the transmission. And then this has 5 clutches. Also, it has 2 holding clutches or brakes, and then it has 3 clutches that cause things to rotate. So brakes, if you recall, stop rotating parts from rotating, and then clutches cause parts to rotate at different speeds. Well, the input shaft here has the P2 planet carrier. So any planetary gear set is going to have a sun gear, a planet carrier with planet gears, and then a Annulus gear, as ZF calls it. It can also be called a ring gear or an internal gear, depending on whose service information you are reading. But I wanted to show you how all of these hook together in this transmission to give us the 8 forward speeds and the 1 reverse. This transmission, like many modern transmissions today, has a remote-driven oil pump. So we've got a drive here that splines to the torque converter that is bolted to the engine. So anytime the engine is rotating, this gear right here is going to spin, and that turns the oil pump, and that sits here in this front cover of the automatic transmission. That normally the oil pump would be bolted to and part of, but now it's offset to the side, like many other transmissions that we are seeing being developed nowadays. And so the stator support shaft and the stator support housing and where the oil pump used to be, the oil pump is going to sit in this little pocket here, and you've got a chain that drives it off to the side. So I'm going to take this stator support housing, turn it around and show you that there's splines in here for one of our two brakes. This is the A brake. They're labeled A, B, C, D, and E. They're almost in order from front of the transmission to the rear of the transmission, but it didn't turn out quite that easy. So that's going to sit in here like this, and then we have an A clutch hub that sits in here on a bearing and rotates until the A clutch, the A brake, applies, and then it stops this from rotating. Now that A clutch connects to a Simpson gear set sun gear. So if you recall, a Simpson gear set has one sun gear that's connected together that is connected to two different planetary gear sets. So this hub right here that the A clutch connects to is actually connected to the sun gear. So when we apply the A clutch, it's going to stop the P1, P2 sun gear from rotating. But we're not quite ready to install that piece yet. All right, also we have the P1 for the planetary gear set number 1, ring gear, annulus gear, whatever you want to call it. It has splines around the outside of it, and it's going to sit in here. It's going to sit in here on top of this A clutch drum, and it has a brake, the B brake, that sits around on the outside of this. So as this P1 annulus gear or ring gear rotates, if the B clutch brake applies, it'll stop that from rotating. All right, then we have the planet carrier for the first planetary gear set, the P1 planet carrier. So that sets down in here. But what I want you to notice on these planet carriers on this transmission, there's little teeth on the outside here, and those end up splining clear to the back of the transmission, and I'll show you that here in a few minutes. But this this Simpson planetary gear set that's in the front of this automatic transmission. So here's the P1, the first portion of the planetary gear set, or the first planetary gear set, and the bottom half of this P1, P2 sun gear. This Simpson gear set, from what all my reading and experimenting with this thing, is a gear set that is used to affect the rotational speed of the P4 gear set, the final gear set that drives the propeller shaft or the output shaft on the all-wheel drive, four-wheel drive versions. So right now we've assembled the P1 sun gear, the P1 carrier, and the P1 annulus or ring gear, all here as one assembly. All right, then the next thing that goes on is our input shaft with the P2 carrier. So it's going to sit right down in here on top of that P1, P2 sun gear. And it has some splines right here. This input shaft does, to where later on, when we get to that point, it hooks to a spline hub that drives a C clutch. And so this one input shaft drives two things. It drives the P2 planet carrier and the C clutch hub. But right now we've assembled the first planetary gear set. We've got the planet carrier with the planet gears for the second gear set. And so now, and the second gear set sun gear is in there because that's the Simpson gear set. And if you recall, a Simpson gear set, besides having a common planetary sun gear, the Simpson gear set developed by Mr. Howard Simpson, patented in 1950, was a 3-speed planetary gear set. So in the front of this transmission, from what I can tell, in the power flow here with the 4 planetary gear sets, is we are using the 3, or not, we're using 2 of the 3 speeds of the planetary, or the Simpson planetary gear set, to control the rotational speed of the P4 planetary gear set carrier. Now, normally with the automatic transmission, with a planetary gear set, with the 3 pieces, the ring gear or the annulus gear, the planet carrier, and the sun gear, we're going to hold one of those 3 pieces from rotating. We're going to put engine power to the other one, and the third one is what goes to the propeller shaft and drives the vehicle. Well, the way they are getting 8 speeds out of this transmission is unique, because there's only two clutches on at one time on this to provide power flow through. Is instead of stopping one component totally from rotating, holding it still, instead of forcing it to stop, through this planetary gear set, it will apply a different gear ratio, a low or a fast gear ratio, to, instead of it being stopped, it will turn at a different speed. And that'll give you a totally different gear ratio, just like if it was a slipping clutch on an older automatic transmission. So they've got kind of tricky with the gear ratios. This transmission is only a double overdrive, so 1st gear through 5th gear. 5th gear is direct drive on this transmission, and then, no, 6th gear is direct drive. 1st through 6th, 6th gear is direct drive, 7th and 8th are overdrive and double overdrive. So we've got the P1 planetary gear set, the P2 carrier installed. Here's the P3 ring gear that's also, or P2 ring gear that's also connected to the P3 sun gear. So we'll set that down inside here. And then we have the P3 planet carrier that's going to sit on top of that. And notice it has little teeth around the outside of it also, because it's going to spline to another piece above. And then we have the P3 annulus gear, or ring gear. And so it sits down here. So now we've got the P1 gear set, the P2 gear set, and the P3 gear set all connected together. This is a compound gear set, but our bottom one is a Simpson 3-speed gear set, which, by the way, the 2 sets of gear teeth on the Simpson gear set, the P1 and the P2, those gear ratios are identical. They have the exact same number of sun gear teeth, exact same number of annulus gear teeth. But the 2 gear sets in the back, the P3 and the P4 that's coming up, those are totally different gear ratios. And these are just simple gear sets, but when you tie them in to the Simpson gear set and to each other, then it becomes an incredibly complex 4 planetary gear set, compound gear set. And the math is incredible to calculate the rotational speeds of all of these components. All right, so we've got P1, P2, P3 installed. Now we have the E-clutch hub that we're going to put on next. It has a set of splines right here that's going to reach down in and connect to that P3 sun gear. So we'll set it down in. So it's going to connect to the P3 sun gear right there. And then we have this C-clutch hub that I showed you with the splines that connects to the input shaft. It's going to sit on here all by itself, not connecting to anything but the input shaft. Here we go. All right, so we've got P1, P2, P3. We've got the A and B clutches, which are brakes, down in this bottom housing. And then we have the E clutch right here and the C clutch right here. The only clutch left is the D clutch, which will be up a little higher. But here's where it If this is all we had, I could show you the power flow through each of the gears and show you the gear ratios and so on. But here's where it gets very complicated. We are going to now start connecting all of these planet carriers and one annulus gear together. So we've got this shell here that drives the final gear set, the P4 gear set. We've got the P4 sun gear right here, and it has the C clutch that can grab it on the inside and the E clutch that can grab it on the inside, but it splines directly to the P3 annulus gear, which is right here. So these teeth right here are what this hub is going to spline down onto and connect. And there's a special snap ring. This transmission uses special snap rings that you typically don't take off from the side where the opening is. You go to the opposite side and take them off from that side first. I've never seen one like that before. But if you read the instructions on removing them, that's how you do it. And so anyway, we've got the C clutch and the E clutch that now can connect to the P4 sun gear, but this is also splined to the P3 annulus. And I know that it's starting to get confusing. It's very confusing. It took me quite a while to wrap my head around how all the power flow actually goes through all of this, but it's an amazing design also. So we've got the P4, starting from the front, we have P1, P2, P3. Now we're up here to P4 sun gear. Is driven by the P3 carrier or the E clutch or the C clutch. Now we also have another housing that's going to go on over the top of this and connect to the P3 planet carrier rather than the P3 annulus gear. And it also has some splines on the top here where it connects to the D clutch, the last clutch in this transmission. But what I wanted to show you of something to look out for in this transmission's been apart already by students, and I wanted to show you some of the possible damage that can occur if you're not careful. When you're taking this snap ring off the housing here, this housing is very, very thin, and you're not supposed to just simply come in with a screwdriver or pry bar or pick and pry that snap ring out because it's so thin. I want you to notice that right here, right there, there's a notch broken out. There's another notch broken out there, and there's several bent teeth right there from people trying to get that snap ring out without using what's called a protector. There's a special service tool called a protector that will slide over this housing, and then it gives you something to pry on as you're taking these snap rings out. And these snap rings are some pretty stiff and stout snap rings. So anyway, this housing, without dealing with the snap rings at the moment, it slides over that other housing that we just put on, and this connects to the P3 carrier. So now we've got a gear set, the control components for a gear set inside of a sleeve that controls the sun gear, inside of another sleeve that controls power from the P3 carrier to the D clutch, and then the D clutch is actually splined right to the final drive planet carrier. Notice we've got these monstrous planet carriers here and a gigantic output shaft. The D clutch is a clutch that's going to connect the housing that we just put on, that aluminum housing, to this output P4 planet carrier. So I'll set that up on here. So right now, notice the output planet carrier can rotate freely. But if that D clutch applies, it will connect this aluminum shell to the D clutch and it will rotate as one assembly. All right, now if that wasn't complex enough, we still have the P4, the fourth planetary gear set, annulus gear or ring gear, that has to sit up on the top of here. And then it is held in place by another gigantic shell that goes all the way down to the P1. Down here on the Simpson planetary gear set, the P1 planet carrier and splines to it, and it also has these little thin pieces that you need to be careful prying the snap ring out. Use the special tool to protect it. So this entire thing splines to the P1 planet carrier down at the bottom, and then it splines to the P4 annulus at the top. So now we've got three shells all nested within each other. All inside of each other, which covers up the P1, P2, P3. The only gear set I can even remotely get to is the P4 up here on the top, which is why I can't even show you the power flow through this thing, because for all of these gear sets to connect from the bottom to the top, remember the input power on this transmission, the input power from the engine comes in the middle here to that P2 planet carrier, and then it goes down to the Simpson gear set at the bottom, then through all these shells up to the P4 gear set at the top, and then the P3 gear set at the top, controlled with the E clutch and the C clutch. Whoever thought of this, this is amazing. It's an incredibly complex and compact design. I'm putting the parking gear on now. So our parking pawl, which this has an electric parking pawl. This transmission does not even need a shift cable connected to it. It can be run all by wire, although it can also have a cable attached to it. It's an amazing design. I've worked for several days now trying to figure out how to show you the power flow through this thing, and I give up. I can't do it. I understand how it works internally, but I cannot demonstrate it because of how this thing is put together. Now, as far as simplicity, though, we've got one B brake clutch that fits inside of the transmission case. And so I've got a case. I've got a transmission case right here. The B1 brake sits inside the case, and then this entire thing just slides down inside of the case itself. On the side of the case here, it says 8 HP70. So it's cast right on the driver's side rear, 8 HP70 as to which model it is. And then something else on this transmission that's unique is right here on the back, there's a plug that you use to check the oil level with. And if you read the instructions on the oil pan, which is right below it, so here's the oil pan. By the way, this oil pan has the filter built into the pan. So if you're changing the filter, it's the entire pan that you're changing. But right here on the side of the transmission pan, there are instructions for checking the oil level on this thing. This transmission does not take regular transmission fluid. It takes a special fluid for this transmission. But basically, the sticker tells you to warm the transmission up to a certain temperature, which it's not full operating temperature. As a matter of fact, if I remember right, it's from room temperature, about 70 degrees to about 113 degrees of transmission fluid temperature. And then pull the plug out of the side of the transmission, which is just right here above it, And if fluid came out, then it had too much fluid in. If no fluid comes out, then add the correct fluid until it does just slowly drip out, and then put the plug back in. So that's the oil pan transmission filter all in one. The valve body on this thing, there is nothing serviceable on this valve body. This has the transmission control module built into the valve body, and it has a solenoid that controls your parking gear right here to put it in and out of park. Everything on here comes as one assembly as far as warranty work and out of the factory work. So any problems at all, you replace this entire thing. I'm sure the aftermarket will come up with some fixes and repairs for commonly worn out valves and so on. All right, well, I wish I could have shown you the entire power flow through all 8 gears and reverse on this thing. As I said, it's an incredibly complex design, but that doesn't mean it's an incredibly complex transmission to work on. It's actually fairly easy to work on, and I'm very impressed with it. A little frustrated I couldn't show you the power flow, but as we see more and more 8, 9, and there's even 10-speed transmissions in the works coming along, I will do my best to get my hands on those and show you how they work. Thanks for watching. Have a good day.